Roshan Sharma is an AI native full-stack builder from New York City. He participated in the 2025 NASA Space Apps Challenge, a global hackathon that brings together diverse teams to tackle real-world problems using NASA's open data alongside space-based data from agencies around the world. He presented Vyuha AI, an agentic AI system designed to act as an autonomous orbital overseer. With low Earth orbit becoming a junkyard of satellites and debris, it is becoming increasingly difficult for human analytical capacity. Vyuha will predict collision risks in real time, act by calculating and maneuvering without human input, and protect using White Circle Security Gateway, which validates every orbital command, preventing indirect prompt injection from hijacking the thrusters or causing intentional deorbit. Check out his work, links in the description box below.
Hello everyone, my name is Roshan Sharma and introducing Vyuha AI, the world's first, potentially, autonomous orbital overseer. You see, the LEO orbit is degrading into a congested junkyard. By 2030, it is expected to have more than 100,000 satellites in that orbit alone, and over 1 million pieces of lethal debris in the orbit. The volume of tracking data has largely exceeded human capabilities. That's why I am taking the bet of autonomous interventions agentic systems for satellites in LEO orbit in this case. Vyuha is a space domain awareness agent that decouples satellite operations from terrestrial control by ingesting real-time open telemetry, in this case at the moment from Celestrak. And for this demo, we will be solely focusing mainly in ISS Zarya. And this is because the telemetry of this satellite is important, because this satellite is worth more than $150 billion in cost with 7 crews, and it has an inclination of 51.6 degrees, which is important for analyzing densely populated cities like New York City in this case, because we have also leveraged New York City's open data in order to analyze the terrestrial impact so that we could not only safeguard satellites in the orbit, but also safeguard the people on Earth, in New York City in this case. So as you can see, we have mainly gathered all the data and propagated through Celestrak, and there are multiple parameters like the altitude, velocity, latitude, longitude, status, and so on. And you can always click on refresh telemetry to get the latest telemetry in this case. However, our system is capable enough to refresh it itself as well, right? So here are some of the metrics like how the telemetry is being used. We have used the natural sciences calculations and maths in order to calculate every single thing like the collision kinetic energy, orbital decay rate, position uncertainty, debris generation potential, ground track velocity, proximity analysis, and communication window. So what does that mean? That simply means this is not a vague idea. We have actually used physics and other fundamentals in order to calculate and make a very deterministic system so that we can actually power our satellite agentic system software potentially with the hardware in future to actually analyze and protect our satellites in multiple orbits, in this case LEO orbit. So the objects tracked in this case are mainly POISK, ISS, and so on, as you can see on the screen, with the multiple parameters on screen, as you can see. How the telemetry feeds into decisions. So as you can see, these are the raw parameters like velocity, altitude, telemetry, age, hours, orbital debris, and so on. And the derived metrics are shown in the screen, and the formula from physics are also shown in the screen. And how the commander, so we have a commander agent which actually analyzes and gives command to our system autonomously. So the entire idea of having an autonomous agentic AI software system for satellites is being done by using these kind of telemetry data, as you can see what we have derived, which are normal natural sciences. Now, in this case, we also have ground situation assessment powered by SODA 3 of NYC open data, which we can refresh. Once you refresh, these are some of the stats that we get from directly pulled from NYC open data, and we have modeled it using various mathematics techniques. So as you can see, it gives some kind of analysis like the ground conditions partially degraded, factors into deorbit risk and maneuver decisions. So our system is able to gather some of the open data which we have integrated here, and is able to score it in such a way that we can see there is a risk of deorbit. Okay, these are dimensions used, how it is being weighted. As you can see, casualty expectations, atmospheric conditions, critical infrastructure, reliability, communication redundancy, and so on. And these are the weight for our machine learning model that we are being using to analyze multiple parameters. These are other parameters that's being gathered from NYC open data in order to analyze multiple features like the atmospheric conditions. As you can see, it is optimal. So what does it do? It tells the overseer optical sensor signal noise ratio degradation plus debris re-entry burn up confidence. So this is how we are able to actually calculate. As you can see, the data is the AQI, air quality index, which is PM 2.5 of as per NYC data. And there are multiple other formulas being used which are very transparent in front of you, which are being used in order to calculate the atmospheric conditions, casualty expectations, ground station reliability, and so on. So this is how I am actually making the system deterministic in order to actually analyze the stats. And what it helps is basically whenever there is change of data, we actually feed these stats back to our system, and we have created a feedback loop which can actually help our system to improve with time. So that's the whole idea. I hope it's clear. There are multiple model input output critical infrastructure coverage input. Why does an autonomous orbital overseer need municipal ground data? So these are the information that I wanted to share, that every satellite pass over a populated area creates a ground risk corridor, right? Because if a satellite is going through the orbit in top of any terrestrial area, then if there is a debris which is going to hit it, there is a high possibility that that might affect the humanity down on the earth as well. That's why we are using and also integrating the ground data from New York City open data. So how does the data flow into the decision? So step number one is ingestion of multiple NYC open data, which has the air quality, emergency incidents, 311 request link NYC kiosk, FDNY firehouses and hospitals. Step 2, modeling. We are using multiple machine learning models and stats, which are Beer-Lambert, NASA EAST3 formula, series R model, parallel R model, coverage model, infrastructure, which number 3 helps us to score the system. And number 4, decide. So what it helps is, it helps our commander AI to actually make decisions using these parameters. Now let's see a simple demo which is being simulated here, and this should reflect the actual use cases. Hopefully I get a chance to work with NASA or ISRO or SpaceX someday. This is an example video which I am going to use. So you can see this is the point of view of the satellite. Okay, this is how it will probably look if a debris is coming towards it. Just simply open it. I have used computer vision models in order to analyze, and you can see our system is actually able to use the OpenCV, which is the open source tool, which is able to analyze the context, like what is actually happening and whether the debris is coming towards the satellite or not, and if it's going to affect us or not. So as you can see, our system is actually able to calculate and identify different objects like the debris with a confidence level which is being scored by the maths and stats that we are using, and the speed as well. So these are all estimates, but I hope you got the idea like how it is working internally. Here are the decision metrics, like how it works fundamentally, and here are all the graphs which you can see with the timeline, like how it's being coming towards the satellite, and we are actually able to analyze all of this data. Here is a detection pipeline trace log. Here is the pipeline config, like how it's working with the latency, and here the analytics of the demo pipeline. Now let us see how it might work. So as you can see, here is a mission log live feed. So what happens is, if you just click on launch debris simulation, so it actually, as you can see, this is a simulation, by the way. So the red mark which you see is the debris which our system is actually able to analyze. So all these parameters are almost real. Only thing is the simulation is this demo. Okay. So as you can see, our Vyuha Commander AI was able to initiate, activate, and collision probability actually exceeded the threshold, right? And this is what we got the information, and our computer vision model was actually able to detect the pipeline. And what happened is basically our system was able to do the reflex action. So it was able to do the manual. That's the theory. This is the spacecraft state and memory. So the idea is basically having all the states, positions, latitude, longitude, and so on in order to actually track, and with time series, we should be able to actually improve our system. That's the theory. This is the maneuver history, like at what time, what date, and so on, what happened, action were taken, the prior thruster, propagate, and so on, and the confidence level, which is again used as parameters to improve our machine learning model, which will improve our autonomous agentic AI system. This is the learning panel. As you can see, there is a success rate count, there is a thread block count, and so on. Latency trend, learned parameters like what it's being learned from the live model state, and policy violation frequency. Now, let me show you what it is exactly. I have actually understood, like in future, there would be something like, cyber attack, for example. So this is the cyber attack playground, where we have template attack as well as custom attack to actually simulate the attacks, how it might work. So today we will only do template attack, but the idea, I hope you are clear about the custom attack, that we can customize the attack as well, cybersecurity one. We have several kind of attacks that I have made a template, and you launch cyber attack simulation. So what actually happens is basically an injection is being done, or a certain type of cyber attack is being done to our agentic AI software. So what happens is our system has guardrails and certain policies which is embedded in our system, right? So whenever there are certain keywords or certain kind of intent that is passed by our AI system to understand whether there is a negative process going on, which is something that is going to harm, like disrupt the system itself, it's going to revert the process which is commanded by the bad actor, but it will not do because it's been guardrailed, right? That's the idea behind it. And there are multiple maths and stats going on, which you can see here, by which I am able to make this whole system deterministic. This is it. Here are the policy violation frequency. So whenever a bad actor actually injects or do any kind of cybersecurity attacks on our multi-agentic AI system, it should be able to track what happened, how happened, and this will be used in order to improve our system with time. Here are also some experience-driven recommendations given by our AI system, like what should be done, recent runtime events, debris simulation history, and cyber attack history. I hope this is clear. Vyuha AI is still in very initial phases. I would say in very idea stages. I would love to collaborate with any kind of people who have the vision to actually safeguard satellites while leveraging data that we have on our Earth. So you can definitely connect with me on LinkedIn. My name is Roshan Sharma. This is the QR code if you will scan. I am always in lookout to collaborate and learn with great people on this earth. So wherever you are watching this from, I would love to talk with you.